Alright guys, today we're working on 5.1d, which is rationalizing radicals in the denominator. So here's an example of two different numbers. One of them has a radical in the numerator, which is fine, and the other has a radical in the denominator, which is not fine. So let's talk about why this is fine and not fine. If we're dividing, right, so we've got 2 and we're dividing by the square root of 2, which is, by the way, 1.4142 blah blah blah. I'm not totally sure how many times this goes into 2 other than like once and then some more stuff, and I wouldn't even know where to go after that, because if I multiply this by 1, I'm going to have 1.4142 on and on forever, and this is just a bunch of zeros, and bring it down again. It's not very easy to divide a number like this. This is much easier to divide, because instead of taking and dividing a whole number by an irrational number that never ends, we're dividing an irrational number by a whole number, which is relatively simple. So we've got the square root of 2, which is like 1.41421356 blah blah blah, divided by 2. We know how to do this, or at one point at least we knew how to do this. So we know that 2 doesn't multiply to be 1, so we put a 0. 2 can multiply to be 14 though, 7 times, which gives us 14. We're going to subtract to get 0, bring down the 1, which again, 2 doesn't multiply to be 1, we put a 0, and we keep going, and so on and so forth, which says that we can divide pretty easily if we wanted to, just dividing by a whole number. This is something we can't do. So when we rationalize the radicals, what that's saying is we need some math trickery to make it so instead of having a number that looks like this, where we have radicals in the denominator, we're going to have radicals only in the numerator. Okay, so let's take care of this pesky thing right now. Let's use example 1 is 2 divided by the square root of 2. So maybe we should actually define this a little more. When we say rationalize, that just means math trickery. I don't know, what are we going to say it like that? To move radicals from the denominator. And sometimes we're lucky, we'll get rid of the radical altogether. But most of the time, we're just getting them out of the denominator. Okay, so example 1, 2 divided by the square root of 2. One of the things we can do is multiply any number by 1. And the cool thing about 1 is that it can take many forms. You're just going to take whatever number you have, you're going to multiply by only the radical in the denominator. So our radical in the denominator is a square root of 2. So we're going to put that in both the numerator and the denominator. And the cool thing about this is that if we look at the square root of 2 divided by the square root of 2, this is going to cancel because this is equal to 1. Anything divided by itself always equals 1, which says we're multiplying this number just by 1, which doesn't change the number even though it's going to look different. So we're going to multiply the numerator and the denominator. So 2 times the square root of 2 is 2 square root of 2 divided by square root of 2 times the square root of 2 is the square root of 4. Okay, and now what we do is just simplify like we're used to. We know that the square root of 4 is equal to 2. We're just going to copy the top part over because there's nothing we can simplify. So 2 square root of 2 divided by 2, well the 2's here are going to cancel. They're equal to 1. So we get 1 square root of 2 divided by 1, which 1 times anything is that thing, divided by 1 is still that thing. So really we just get the square root of 2. And notice that we no longer have radicals in the denominator, so this is the final answer. And if you were to type this in your calculator and this in your calculator, both of those would give you a similar decimal approximation. They should give you the exact same one if you use the same calculator. Okay, so example 2. 7 square root of 5 divided by the square root of 2. Again, we do not like dividing by that radical, so we're going to multiply by a fancy 1 in order to get rid of it. So whatever radical is in the denominator, let's just multiply by that radical in both the numerator and the denominator, because this is still 1. So 7 square root of 5 times the square root of 2, we're going to get 7 square root of 10, all divided by square root of 2 times the square root of 2 is the square root of 4. Okay, simplifying. Can't do 10, that's only 2 and 5. But 4, I know the square root of 4 because it's perfect squares and they equal 2. So 7 square root of 10 divided by 2, there's nothing else we can simplify. These aren't numbers that we can divide together, so we're just going to leave it as 7 square root of 10 divided by 2. We're done because we got the radicals out of the denominator. So we could approximate this in decimal form and then divide just like we did up here, and we could get a nice simple answer if we wanted to. It'll go on for a long time, you know, forever. but it would still be an easy process for us to do. Anyway, 3 divided by 2 squared root of 3. So we've got both a outside number and an inside number. We've got the radicand and the radicand is what they're technically called. We're just going to multiply by whatever is on the inside of the radical. You could multiply by 2 squared root of 3 in both the numerator and the denominator. That's going to leave more work for you in the future when you're trying to simplify. So instead, let's just multiply, not equals, let's multiply by the square root of 3 over the square root of 3. Square root of 3 divided by the square root of 3. 3 times the square root of 3 is 3 square root of 3. 2 square root of 3 times the square root of 3 is 2 square root of 9. So then we know that the 3 square root of 3 can't be reduced, but the square root of 9 is just 3. So we're copying my 2 over. Again, I have the same number in the numerator and the denominator, so eventually they're going to cancel, just like this did here. We're left with the square root of 3 over 2, which is good. We got the radicals out of the denominator and into the numerator. And again, if you type this in your calculator and this in your calculator, you should get the same decimal approximation. Okay, last example. 7 square root of 2 divided by the square root of 6. So again, I'm just going to multiply in the numerator and the denominator, by whatever radical is in the denominator. So multiplying 7 square root of 2 times the square root of 6 is 7 square root of 2 times 6 is 12. Divided by square root of 6 times the square root of 6 is a square root of 36. Okay, we've got a bunch of things we can simplify. I know the top square root of 12 is 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. You can make a factor tree. I just knew this one off the top of my head. And then the square root of 36, 36 is a perfect square. So you could do a factor tree if you want to, but I'm just going to take the square root of 36 and get 6. 6 multiplies by itself to be 36. So that's our answer. Okay, square root is asking for what number do we multiply by itself to be that number. So we've got a 2 multiplies by itself, so we're bringing a 2 to the outside, so 7 times 2 square root of 3, all divided by 6. And I'm going to notice here that 2 over 6 is the same thing as 1 over 3 if we divide both by 2. Same thing on the top and the bottom, so we're going to get 7 times 1 square root of 3, which is a 7 square root of 3, and then 6 divided by 2 is also 3. And this is simplest form. There's nothing else we can simplify in the numerator or the denominator, and there are no radicals in the denominator. Okay guys, come get